Dear fellow coders, welcome to One Little Coder. This is day 8 of 8 days of Streamlit, which means this is the last day where I was teaching you for the last 7 days to build one Streamlit application every day. We have gone through a lot of different application with machine learning, without machine learning, NLP, and today we are going to see something very special, and right now you are seeing it on your screen. And believe me, this is really special because I've searched online for this tutorial. I don't see any similar tutorial available at all. If you see any similar tutorial, please let me know in the comment section. I would really love to see how they've coded. So what we're going to build is we're going to build a real-time live data feed data science dashboard. So it's a data science dashboard, but it updates in real time or near real time. I'll show you how this real time thing works. It's not actually real time. I can call it near real time. So where do you think this could be useful? Let's say you want to display a finance dashboard. Let's say you want to display a stock market dashboard. Let's say you want to display a Bitcoin dashboard. Or let's say you want to monitor the trains that are available in your country. You want to monitor the flights that are available in your country. Or you want to see the weather. So these are the places where you usually see a live data feed, or you can make repeated API calls like Twitter data, right? You've got streaming data coming in, or you have got system log data. So these are the places where you could be having continuous data input, and sometimes you want to see this live real-time data on the dashboard. You don't want to see a static dashboard. You don't want to have a daily refresh. You don't want to have an hourly refresh. You want to see something in every second changing. And if that is a use case that you wanted to make, and that is exactly what we are going to make today in the 8th day of 8 days of Streamlit. And without further ado, I'm going to take you straight into the code so that we code and learn how to build this real-time Streamlit data science dashboard. So as usual, I've got two files in my project folder. So the first file, let me first stop this. Yeah, the first file that I have is app.py file, and the second file that I have is requirements.txt. The requirements.txt, we have got numpy for, we are doing a little bit of random and mean. We are using numpy for that. Pandas to read a data frame, and plotly read a CSV file, plotly.express to make interactive charts, and Streamlit, of course, the core engine, the brain and mother of all these things that we are building. And then the app.py file is where we are actually building the file, and I'm going to show you line by line, every single line. So I would request you to probably open a new window and then start coding as I explain you every single line. So that is a better way for you to learn Streamlit or learn this application than just looking at me and watching it. I'm going to close the files tab, and then I'm going to increase the size of this. I hope this is legible. I'm going to close this as well, so we don't need the minimap. Okay, bye bye minimap. Okay, at this point you can see the code. So the first line, Streamlit, we want it for web development. Okay, so that's clear. And then the next line that we have, numpy, is for np mean, np random, and those are the two things I think we are using. But as we see the code, you can see basically we are using it for numerical computation. And pandas, read CSV, and a little bit of data frame filtering, data frame manipulation, I would call it. And finally time to simulate a real-time data, we are going to do a time loop. Okay, and then finally for interactive charts, we are going to use plotly express. So these are the 5 libraries. Time is already, it's part of base Python, so you don't have to deal with time. But Streamlit, numpy, pandas, plotly.express. So if you're going to try this on your local machine, make sure that you have got these 4 packages, Python libraries installed. Otherwise, I would upload this code on GitHub, of course, and then I would link that in the YouTube description. So what you can do is when you download the repository, either you can install these things separately, or you can do a pip install requirements.txt to make sure that you install all these libraries. So you can choose either way that you prefer, but install all the packages before you proceed further. Next, we are going to use a CSV file that I just found online. So I'm going to show you the CSV file here. So this is how the CSV file looks. It has got a bunch of columns. I would link this data source definitely in the YouTube description. Credit to the author who has put it together. So we have got age, job, marital status, education, default, whether you defaulted, credit defaulted, balance, housing, blah blah blah, lot of information. The columns that we are going to mostly deal with, we're going to deal with age, we're going to deal with job, we're going to deal with marital status, and yeah, I think we're going to deal with balance as well, the amount that is there in your account. So these are the columns that we're going to deal with. So the first thing is read_csv. I don't know if you know this thing, but it's not just that you can read from your local machine using read_csv. If you have anywhere on the cloud as well, if you have the final point where you have the CSV file online, you can still read it. So like you see, so this is the raw CSV from GitHub, and I'm just directly reading it from that repository. So as simple as that. So I'm going to write a comment saying read CSV from a GitHub repository repo. That's fine. The next thing is we want to set up a bunch of page configuration. I'm not sure if we have ever done this in the last seven videos, but if you see, this is quite important if you're going to deploy this. For example, where does this page title work? So if you go through the application, like for example, right now, you cannot probably see the favicon, but let me take you to the source code and show you if I can show you. If you go to the source code, there is something called title. Let me run this application and take you to the source code. Let me refresh this, please. Yeah, I'm refreshing this at this point, and it has loaded, and you can see the head. Within the head, you can see title. Where is title? You can see title. So real-time data science dashboard. So this is quite important. Let's say you're going to launch a commercial application. Let's say you're going to have a website that is deployed online, not just part of your internal organization. Let's say you want to deploy or create a SaaS product using Streamlit. So this is extremely important for something called SEO. So if you're not familiar with SEO stands for search engine optimization. One of the important things that Google crawlers or Google spiders would look on your website is what is the title of your website, what is the title of your app, what is the title of the service that you're providing. So title is something that is important. It's not just this title is actually rendered on the top of your browser. If you hover on your tab, this is something that you would see. Also, you can go to the source code and then see. So for example, I can show you, I can edit this and show you. You can see that it doesn't change here because this is a completely separate title, and this title is something that is important for the crawlers, spiders, whatever you would like to call it, all this search engine to read and understand what you are delivering using your application, the product, SaaS, whatever you would like to call it. So this is important. So having the ability to set the page title is important. This is favicon. So I'm not sure if you are familiar with favicon. So favicon is the top small icon that you would see on every tab. So that improves user experience. So that favicon is something that we have set up here. And then what is the page layout that you want? For example, if you see this thing at this point, it is a wide layout. So you can have like all the Streamlit applications that we have built until now, you would have seen a narrow layout. So this is a wide layout. So you can cover the entire full screen with this thing. And this being a dashboard, I think it makes sense for us to have a wide layout so that you make use of the real estate that you have got. It comes with a little bit of downside. For example, now when you have a drop down, it's going to go full wide, then you have to deal with columns, all those things, but still I think it makes sense to have a wide dashboard. So this is how the dashboard looks. I honestly feel that it looks amazing that you have a live real-time dashboard. So I've worked in marketing agencies before. Companies used to charge heck lot of money. Whatever I'm talking about is like 6-7 years back. Companies used to charge heck lot of money. I'm not talking about Indian currency, even I'm talking about US dollars, to set up social media live feed that looks like this. Whatever we just showed, live likes, live tweets. So that is usually part of social media center, and companies used to charge a lot of money to set this up on an LCD monitor and this thing. And now today, as of now, at the end of this video, you would be able to make this using an MIT license, free solution, free application Python library, and you would be able to even deploy it for free, internally, externally, using Streamlit Cloud or Hugging Face Spaces. So we have come a very far along since the time that I'm talking to you about. So this is extremely helpful if you're in marketing, sales, a lot of different finance. personal monitoring, computer monitoring, log monitoring, status monitoring. This is going to be extremely helpful, believe me, and I hope like you focus on this tutorial till the end and then you learn this thing. So this is the configuration part. Now next we are going to talk about the title, the actual title that we have here. Not the title for SEO, not the title for web crawlers, not the page title, but the title that you see at the start of the page, which is what we are going to say st.title, and this is the title that you see here. So real-time live data science dashboard, so I can call it live data feed. And again, I've not called it with any business case, right? I'm not calling it let's say a marketing analytics dashboard. I'm not calling it a finance dashboard. I'm not calling it a Bitcoin dashboard. I'm just calling it a real-time live data science dashboard, because right now I'm not delivering any insight. I'm not focusing on what insight I want to give. I'm focusing on teaching you how to actually build the dashboard. Now I'm not talking about business analytics. I'm talking about pure coding here. So you might have to put on your business analytics hat and then think, what do you want to actually deliver? What kind of KPIs your business stakeholders might be interested in? What kind of KPIs might help them drive business decisions? So that's a different discussion you need to have if you're building a dashboard like this. You need to do wireframing. I'm not doing any of those things. I'm just going to show you 3 sections or 4 sections, to be honest. 4 sections that typically usually dashboards have, and how do we build those 4 sections using Streamlit, and how do we make this near real-time or live data feed. So that's what. So the first section that we are going to be interested in is the filter section. So any dashboard that you take usually in your organization, a CXO dashboard, or even dashboards at managerial level, business head level, you would see the top line is usually filled with filters. So the next section below that is usually the top KPIs, KBMs, whatever you would like to call in your organization, OKR, KR, whatever you would like to call it. The top section would have all the KPIs and how they're trending up, trending down, what was the week over week percentage, some kind of indication that where are we with respect to our goal. Are we good? Are we bad? So something like that. So first filters, second you have got the KPIs, and then the next level is those important charts that can explain what's happening with those KPIs. What kind of drivers you have got, does it impact your KPI? If the drivers change like this, what kind of change you have got with your KPIs? So that is like the second level. So the first filter, second KPI, and like in terms of displaying data, the next level is your chart, and then finally I've got a detailed view of actual data. So sometimes you might have multiple levels of chart, but like the approach that I'm saying is filters, KPIs, charts, and data tables. And this is what we are going to build today, and this is a very good practice if you're going to build a dashboard. Usually like people who just start building dashboard, they may not follow this structured approach, so they might start putting things scattered around here and there. But this another good practice to have this kind of similar structure where you have got filters, KPIs, charts, and detailed data view. One more thing to note with respect to Streamlit, you can either have this drop down here, filter, or you can have it in the sidebar. Right now I'm having it here, but if you find this a little uncomfortable, like why do I have to have this here, so you can always have it in sidebar, and how to do that. It's quite simple. All we have to do is st.sidebar.select box. So instead of saying select box, st.select box, we say st.sidebar.select box. So I come back here, rerun it, and yeah, when this runs, you can see that we have a sidebar. So you select something here and you close it, and you open it, select something here. So the only problem in putting something there is sometimes business stakeholders, not every business stakeholder is tech savvy, so they may not even know that there is something that exists there. So putting a filter at the top, it's more intuitive, but more noisy as well, right? So you're just taking up some real estate, so putting it there, it's fine. So right now I'm leaving it aside. So this is the pay dashboard title, and then the next line is filter, top filter, I should say top level filter I'm calling it, but this is where you need to have filters. And the way we are dynamically printing the filter value is we're taking the job column from the Streamlit, data frame, and then we're printing the job value. So we're taking the job column from the Streamlit, data frame, and then we're printing the filter value. So and we are taking the unique of it. So at the end of this, we are actually getting the list, and that list is sent as the input values for the job filter drop down. So this drop down helps us select a particular job title, and that goes inside this object as a string called job filter. So the next thing, now forget everything, the next thing that you're going to see is something that you wouldn't have seen before in most of the Streamlit application. This is called a Streamlit Empty. So I'm going to straight dive into Streamlit application, Streamlit documentation, and I'm going to read whatever they are going to explain about st empty. So st.empty insert a single element container. Inserts a container into your app that can be used to hold a single element. This allows you to, for example, remove elements at any point or replace several elements at once. So what we are going to do here in this real-time dashboard is we are going to replace elements, which means, so how do you see a video? So imagine like let's go all the way back like 100 years. We used to have only photos. Now you started seeing videos. How do you see videos? Like even the video that you are watching now, you are watching bunch of images at 30 frames per second, which means all these images are stitched together in such a way that for every second you are seeing 30 frames. That's what is video, right? 30 fps. The same way, what we are trying to do here is we are trying to refresh these elements that we are going to show. So the elements that you see here, we are going to refresh these elements in such a way that these elements are replaced in the same location. But for the user, they're going to feel that, okay, this is getting updated in real time. But what we are actually doing is we are replacing this chart, replacing this chart, replacing this table, replacing this number, replacing this KPI, replacing this KPI. We're replacing all the components in this dashboard, but we are giving that near real-time effect by replacing it, not by changing the location. And for that, we need st.empty, because all of the things that we are going to change is going to be a single container. So you just have to change the single container. So if you make any mistake in this part, you're going to have a difficult time, because the elements might get duplicated, elements might get repeated. We don't want that to happen. So we want them to get replaced exactly where they are. So that's why we are first creating an empty container. So this container, which is called placeholder, is going to hold everything together, and you're going to just see how it's going to do. So what they have mentioned is insert a single element container. So we're going to say creating a single element container. Next, just a rusty coding. Like I'm not following a proper coding practice here, because immediately I'm moving on to the data frame. So either I should keep all my data cleaning separately, like if you want to do enhancement, do this thing, but you know, I've spent so much time in making this application. I didn't have time to think about where to put the data filter. So this is data frame filter, and what is it doing? It's, so whatever filter that you select here, so if you select somebody is student, that student is a value that gets assigned to job filter. Now you want to filter the data frame for that, so that the final table that you see here has only that particular value. So if you select somebody retired, so you want only the retired value here. So you can see retired. You select a technician for somebody, you want only technician here. So that's what we are trying to do, and for that we need to filter the data frame. Next, I'll let you know why we have it inside a for loop in some time, but let's leave the for loop aside and then focus on the rest of the code. So the first thing is I'm trying to get the age and I'm multiplying it by random number. Why random number? So every time you want a different number, right? Right now my CSV doesn't change. So I'm trying to give you an effect. I'm trying to give you a feeling. I'm trying to simulate it in such a way that you can feel that real-time effect. But my data feed that I've got is a CSV, and that doesn't change. Like you can see, as much as I change, it doesn't change. But if you have an API, or if you have a data feed that gets updated every second or every minute, for example, if you want Bitcoin price, let's say you want to show a dashboard with the Bitcoin price, you can straight away go to CoinDesk API, and then you can see you would get a JSON file that gets updated every minute. So for example, right now 2109 is what you see the time, and you can see the Bitcoin price 42,685. But in 1 minute you would see this Bitcoin price changing. Like let's come back and see. So in 1 minute this Bitcoin price would change, which means if you refresh your application every minute, you don't need to do any of this data manipulation that I'm doing to show you that there is a real-time data. So let me make it clear again. In my case, the data is not dynamic. In my case, data is static. So because I've got a fixed static data, I wanted to show you how it looks when you have dynamic data. To simulate that, I'm using a for loop that will go iteration by iteration for 20 iteration. So you can see 200 here. So for 200 iteration, this is going to go again and again and again. And every time this iteration happens, I'm just multiplying it with one random number so that the age when you look on the dashboard looks different. Because if you have the same number, let's say I'm showing you the same age, let's say age is only 40 all the time. Would you understand whether there is a refresh happening? Would you know how would it look if you have a actual real-time data feed? You wouldn't know. So to simulate that, I am iterating my entire code base, which is generating that container for 200 times, and for every single time I'm generating random numbers. And this is generated using np.random.choice. Now going back to CoinDesk, so what do we have? 2109 and our price is 42,685. Let me refresh this. Now it's refreshed 2103, and you can see from 685 or something, it has become 639. So if you have a data source that is like this, that gets updated every minute or every second or every hour, depending upon what kind of data source that you have got. Like there are train data sets, there are stock market data sets. Like some stock market data set have daily update. Some stock market data source have got seconds, updated by seconds. So it is basically coming down to the kind of data source that you have access to and the kind of the price that you're ready to pay. Most of these live data sources are not free, unless if it is part of your organization, of course you don't have to pay anybody. But if you're going to use any public data source, let's say you want to build a finance dashboard, let's say you want to build a stock market dashboard, then you might have to pay money, actual money, to get data sets, data sources, data feeds that are close real time, near real time. So that's something that I'll leave it to you. But the reason why I've got a for loop, the reason why I'm having random number is to give you that feel that every time you look at this dashboard, like something is changing. Like this number will constantly change for every iteration, and that is something that I'm achieving by multiplying my existing age with a random number that is generated between 1 to 5. I'm using np.random.choice. I'm doing this for age, and I'm adding it to a new column in the data frame called age_new. I'm doing the same thing for balance, and I'm adding it to a new column called balance_new. So I'm going to call this near real time /live feed simulation. Okay, so this is like the matrix. So I'm just simulating it so that you know that something is happening. After that, we want to create our KPIs, the key performance indicators. Again, this is all about your organization, what kind of information that you want to give it to your stakeholders and what kind of value that they're going to get. So this is again subjective, but just for the sake of tutorial, I'm creating 3 KPIs. One is average age, second is count of married people in the data frame, and then the third one is the balance, the average balance. So you've got average age, count of married, and average balance. And I'm not going to explain you how I'm filtering. I assume that you know pandas and you know how do we filter. So average age is basically we have taken the age column and then taken mean, and count of married, we are filtering our data set for married and then taking a count of that, and then again adding a random number to it so that the number looks different. And then finally we've got a balance, and the balance is again mean of whatever we have created, balance new. So we've got 3 KPIs. Now comes one level down in the UI, user interface part. So now we are going to define a container within the placeholder. So we created an empty the placeholder, right, container, and within that we are going to keep all the columns within a container. And sorry, did I say columns? I'm sorry, components. We're going to keep all the components, Streamlit UI components within that. And then the first component that we're going to create is 3 columns. We're going to create 3 columns. We're calling it KPI1, KPI2, KPI3. It's going to give you 3 different columns. And in all those 3 columns, we're going to add these metrics that we just created. The first column, metric age, second column, metric merit count, third column, metric account balance. So now how do we define metric? So the way we define metric is Streamlit has a very nice method called metric. If you're not familiar with that, and if you're still using the old method of using a markdown and then editing, changing the color of your text, then you should migrate your code to metric. Metric is really nice. So in metric you have 3, or I should say 4 important arguments. One is the label. What is the label of the metric? This one that you see. The second is the value, this part, whatever the value that you're displaying. The value is not just integer. Value can be integer, string, float, whatever you would like to have. So for example, you can see I'm using an if string. Like when we come there, I'll explain you what is it. And then the delta talks about what is the difference. If the delta is positive, it's going to give you the green color arrow, and if the delta is negative, it's going to give you the red color arrow. And if you want to inverse the colors, then you have an option called delta. I think delta inverse or something. We can check it out. So if you want to change the color, you can still change it. So by definition, positive is green, negative is red, and that's what you see. So you have label, value, delta, and value could have string as well, not just text. So the next thing is, you can see that I'm using fstring here. Fstring, if you're familiar with the Python 3 universe, fstring is quite common. A lot of people love fstring. So instead of using a dot format where you wanted to take a string and then do something, you can use fstring here, which means you can do calculations within that, and then it's more readable. So I've just added a dollar here, I've rounded it off, and then I'm displaying it. So all these things are happening here, so it's quite easy. So we have 3 metrics defined. First we are defining the columns, and then we are defining metrics. So first you can see that there are empty spaces. We are just dividing it, then we are filling in those spaces with metric, a Streamlit component that helps us to display the metric. Then we want 2 more columns, right? After these 3 columns, we want 2 more columns, and I'm calling it fig col 1, fig col 2. So let me add create 3 columns, and let me add fill in those 3 columns with respective metrics or KPIs, and then create 2 columns for charts, and we are going to fill in those 2 columns with chart with column 1. So again, you can see the difference in the way we are adding it. Here we are saying KPI dot. You can use either the dot notation or you can use the with notation like this. You can have with column name, or you can say column name dot. You can either add a component to a column like this, or you can do like this as well, where you have got with fig col 1, which is the column name, and then I'm going to add a title saying first chart, and I'm going to create a Plotly Express density heat map. Forget about what chart I'm making here, it doesn't matter, right? Because you're going to fill in with a different chart that is going to help your business. So that doesn't matter a lot, but what would probably matter is, what are we doing? So I'm using st.write to display the Plotly chart like this, you can see. And then same thing, I'm having a second column, and in the second column I'm making a histogram, and I'm just displaying the histogram. Now these things are done. Now again I'm giving st.markdown for a new title, and then this title says detailed view, so I can call it detailed data view, and then within that we are just displaying the data frame. So whatever the data frame is, we are displaying it, and we are going to make this sleep for half a second, and for every half a second it is going to refresh. You can keep it 1 second, you can keep it half a second, it's completely up to you. Right now, because I'm just simulating it, it doesn't matter a lot, but when it would matter, if you have limits of API. For example, let's say there is an API that you're going to use which has got only 30 requests per minute. If you have half a second, then it means you would, like, by 1 minute you would have hit 120 calls, so you would have hit the API limit by even less than that. So did I say, yeah, 1 minute, yeah, I'm right. So which means I just was thinking whether my math was right. So you have to look at the API call limit, what kind of cost you're going to pay, and based on that you can update it. For example, let's say you have got the Bitcoin price that we just discussed, CoinDisk. If that itself is going to update every minute, then there is no point in updating your app every second, because you would be unnecessarily making 60 calls for which you wouldn't have got any data refresh. So this time to sleep is something that you have to give based on the input data sources, refresh cycle, your API calls, and yada yada, all these factors. Now for every single time, this is going to go on a loop, and then it's going to update. So for now, for the demo purpose, I've got a for loop where I'm using this range value and taking seconds. But what you can also do is, instead of this, you can do a while true. So the reason why I'm not doing while true is because, like, I'm not going to deploy this anywhere where it is going to be real time, right? But what you can also do is, instead of this, you can do a while true, which means this dashboard is going to always refresh unless until you take the dashboard down. So you can either do this, or if you want to demo it internally before you deploy it, like maybe you can have a test code with for, and then when you want to deploy it, you can have a while code. So while will make sure that you have an infinite loop, and then it would just keep on updating, and that's it. Our app is that done and dusted. So if you want, you can add you can add a caption, you can add whatever you want, like below this. Like right now I don't have anything. Like if you want, say, markdown, if you want to add a guide to your internal documentation or something, you can do all those things like below this. But again, like, you don't want your dashboard where people have to scroll down like 5 scrolls or 10 scrolls on all these things. It's always good to keep your dashboard simple, minimalistic, that delivers the key performance indicators. So whatever the purpose is, right? It could be a monitoring log monitoring dashboard, system log monitoring dashboard, or you could be a trader, you want to just hit some trades. The good thing with Streamlit dashboard, unlike a Tableau dashboard, or unlike a Power BI dashboard, or unlike a ClickSense dashboard, the good thing with Streamlit dashboard is, this is in Python. What does it mean? It means, let's say you're building a dashboard for stock prices. Like in India, there is a company called Zerodha. That's like Robin in the US. They have got a very good architecture for stock trading. Almost everybody uses it. And Zerodha has got an API called Kite API. So if you're building this in India for a stock market, you can automatically make Kite API. Like for example, within this, now you can call a function. Now let's say you have a function that says sell order, right? And now all you have to do is you have to invoke this function, and then you have to execute the sell order. So that's completely possible in a lot of cases. But yeah, like for example, you have a system log monitoring dashboard. Something goes wrong, so you can use algorithms to detect anomalies, and then you can send a Slack message, you can send an email, you can send an SMS. You can notify people when something goes wrong. So the potential is enormous because you are using a Streamlit dashboard over any other existing proprietary solution. Like forget about free of cost. Like let's for a second even not say that Tableau is so expensive. Let's not say that Power BI is expensive. Forget about that cost aspect for a minute, and then think the first advantage we just discussed is it's pure Python. Like it's Python code for you. So you can do machine learning, you can do anomaly detection, whatnot. You can do forecasting, you can do heck a lot of things that is possible with Python. The second thing is technical debt. What is a technical debt? For example, now if somebody, let's say I leave the organization today, I've resigned my job, somebody else is going to come, all they have to do is look at this code, look at the data source, make changes. You have got comments in there, they can just simply read through it and then they can make changes. But that is not entirely true with Tableau and Power BI and ClickSense, because there are a lot of different places where you can add a variable, delete a variable, edit a variable. So the technical debt is huge there. So reason number 2 is technical debt. Less technical debt using Streamlit, more technical debt using existing proprietary solution. The third most important solution is reusability. For example, now all you have to do is copy this code, give it to your colleague. They can just change the data source, change the column names, and they have an immediately new dashboard ready in just couple of hours. But that will not be entirely true if you're using Tableau or ClickSense or Power BI, because replicating a dashboard would take a lot of effort, even if it is just simply replicating. Not every dashboard is simply plug and play data source. The way people build dashboards, everybody has a different way of building it. But if you talk about a code, this is it. You just maybe you put black on top of it and then you format the code. That's it. You have some standardization. That's it. So reusability is an important component. So we discussed a couple of reasons why I prefer or I advocate people using Streamlit dashboard. One, like the reason we just discussed, which is reusability. 2, technical debt. Technical debt is like almost minimal here unless you have a completely rubbish shabby code. And then 3, it's a Python interface. You can do anything on the planet that you want. Image recognition, anomaly detection, send a message to Slack, create something, send an email message. You can even, I think, call an Uber or something. Like, you can basically do anything that you want because it's a Python interface, and that gives you enormous potential. So let me run this. I think I've done a lot of talking. Probably you must have already understood the code. So let me run this application. Let me call something and then click admin and then see now you can see the age is changing, married count is changing, account balance is changing, -300, -200, 688 something. The heat map is changing, the histogram is changing. You can see the value only for admin. Now I can go and then say, okay, I don't want admins, I want only unemployed. And then I can see unemployed. Okay, what are their age, the data, and then the heat map. And then you can see, like, I can actually see like a lot of unemployed people are like married. Again, this is simulated data. Like, I'm not trying to infer any insight from this, but this is how you do, like, this is how you infer insights from the dashboard. It's not just to appreciate that you have done a great fancy job, but it's to actually deliver business value. And then I strongly believe that a dashboard like this, where you have got real-time live data feed, data science dashboard, is where you can actually deliver business result with all those advantages we just discussed. And I really hope this tutorial was helpful to you, and I hope this 8 days of Streamlit that we did was helpful to you, learning something new. It was a huge learning experience for me, every time debugging something, changing the code, and I hope the same thing for you. Please let me know in the comment section what you feel about this series. If you want me to do anything like this in the future, let me know again. Otherwise, I would upload this code, the entire code base in the GitHub repository, and then link it in the YouTube description. You should definitely check it out. And huge shout out to Streamlit for this amazing product. Otherwise, I hope you stay safe, take care of your family, and happy coding.